So, ladies and gentlemen, I need a level 0. I'm going to start off by saying that lesson 10 is starting today, but it is also ending next week. Not ending, but we are going to try to wrap it up before the break so you don't forget everything that I'm teaching you and that you're learning with the long break that we have. So I do want you to have a piece of paper, and I did suggest some colored pencils would be helpful. I do have some in front of you. You are welcome to borrow mine. Before we start our problem of the day, I wanted to start off with a song that will help you know how we're going to be multiplying decimals. So please take a look at this as we start.
Let's use our number sense to multiply 9 and 100 by 5 and 1/10. We multiply the 1 to get 109. In the next place value, there's a 5. X holds the place on the second line. We get a 5, a 0, and a 45. Write a line, a plus sign, tally up the score. 2 get 15954.
Let's think about the reason of all this suffering, so I round into a simpler number than we could easily see where the point needs to be.
Now let's get intense and multiply 92 hundredths by 3 and 2/10. Multiply the 2, get 4 and 18. In the next place value is a 3. Write an X to hold the place, and then we get a 6 and a 27. Add it up to get 4, 4, a 9 and a 2, and there's one step more.
Let's think about the reason of all this suffering, so by rounding to a simpler number than we could easily see where the point needs to be.
Here's another way to place the point worth trying. Look at the numbers you are multiplying. Count the number of decimal places in the product. Move left that many spaces.
Let's think about the reason of all this suffering, so by rounding to a simpler number than we could easily see where the point needs to be. Let's think about the reason of all this suffering, so by rounding to a simpler number than we could easily see where the point needs to
So, ladies and gents, that is basically what we're doing today. We are multiplying decimals, and I liked it because it was catchy, and I liked it because it talked about estimating to help you make sure you're on the right track and helps you place the decimal in the right spot. But it also talked about counting decimal places, which is really the newest part. You've multiplied numbers before in your past math, but now we're going to be having 2 decimals in both of the factors that we're multiplying. So that's really the only change, is that you have to make sure you know how to place the decimal point in the product in the right spot. So that song was the how. Now we're going to practice, and our first question involves state tax. So what happens to a price when you add tax to it? Does it go up or down? So we are going to figure out how much tax is being added to the price. Now I'm going to use this example to review what the song just said. So you don't actually have to do this one. Just listen up. So before we do what the song said, I want you to see the connection that you already have with what you know about fractions. So just hang tight with me. How can we show the number 24.5 as a mixed number? It's right here, 24 and 5/10. If we do what we know about If we use what we know about mixed numbers, 24 and 5/10 can be written as an improper fraction. Remember the multiply add trick? Yeah. So that's why you see here, and this is in your purple packet. Sorry, I forgot to mention that. If you wanted to look at that, it's right there as well. That's why you see 245 over 10. being multiplied by the fraction version of the other decimal in the problem. 0 and 8/100 is the same as 8/100. So all I'm doing is I'm showing you the connection that multiplying decimals has to fractions right now. Do you have to use fractions when you are multiplying? No, but I want you to see the connection. And now when we multiply across, it's getting 1,960 over 1,000. 1,960 is the same as 1 whole, and then 960 thousandths. Pause. Okay, Mrs. Trumble, that's a lot of fraction work. Yeah, it is. So you don't have to use fractions, but look at the answer when we're using the algorithm that the song was talking about. You have 1 and 960 thousandths. So the fraction way is going to get you the same answer, but you just have to see the connection. Oh, it's the same as what we would do with fractions. Now we're just doing decimal versions of it. So what you see here, and this is why I wanted you to have colored pencils, is when you have multiple digits here that you're going to be multiplying, this is only a one-step problem because the zeros, you don't really have to multiply everything by 0 and add up nothing. So zeros actually make your lives a little easier when you're multiplying, but they're tricky because you have to make sure you're putting zeros in the right spots, and we're going to practice that. Don't worry. The biggest, newest thing is that you have to count the decimal places in each factor and then move from the end of the product over to the left that many places to place the decimal point. Yes, estimation helps as well, like the song said, but the scoop and counting method also works every time. And I think that's the easier way because sometimes you will estimate wrong. And so we don't want to do that as a mistake. So let's try one. 4 6th graders are working on a project. This is actually one I'm going to want you to try. They are going to paint a large banner and they need to protect the floor. They measured the floor, which is 3 500 meters by 3 658 meters. Didn't read that right. 3 658 thousandths meters. How many square meters of plastic do they need to cover the entire floor? So here's the length. Here's the width. We're finding area by multiplying those two decimals together. What you notice here, though, is that there are a lot more digits than what our previous example was. So set it up on your paper. Try to multiply and try that counting method. And we're going to go over it in just a few minutes. But I want you to try it instead of just watching me do it. So, no. But you do have to add zeros when you're multiplying. Do you want me to walk through this one for you?
Yes.
You try it, and then I will walk through it. You try it first. That's the right setup. Perfect. You do not need to line up decimals when you're multiplying. So that's why you're thinking that you need to annex zeros. Good question. You do not need to line up decimals when you're multiplying. Pretend the decimals don't exist. Set it up, put the decimals in because you're going to need them. But you do not need to line up the decimals when you're multiplying. So that is the first level. I'll go to the 0. you have an extra one. Yes, if you were done, that's what you would do. With the All right, so these are a little bit time consuming because there's a lot of pieces to it. There's going to be a lot of opportunities for you to practice. I want to make sure you're going down the right road, and for some of you, you might need a refresher on all of the steps needed. So I want you to see what I did for color purposes. Here's what it looks like with fractions. So we're not going to be doing the fractions, but this is another way to think about it. Writing mixed numbers in place of the decimals and then multiplying those numerators and denominators. That is a way to figure it out. But I want you to be practicing the decimal version more so today. And when you're multiplying, you have to look at each number and here's why I'm saying maybe colored pencils will help you. Look at my 5 and look at the blue lines. Do you see that? 5 times 8 was my first step. I wrote down a 4 and I kept the 0. 5 times 5 was my second step. And then I had to add a 4. That's how I got 29. My blue goes to the 6, from the 5 to the 6. And then I needed to add that 2. So I'm getting 32. And then my final step was 3 times 5, which is 15. Add the 3 and I get 18. So the first level, so to speak, is the 18290. Here's where we have to be careful when we're doing a 3-digit by a 4-digit multiplication problem. When you go to the next digit, which is the 0, that is in this second space, which is another reason why turning your paper and using those columns is highly suggested to keep everything in the right column. See this red X here? Yeah. That is a placeholder because the first answer to 0 times 8 needs to be in line with the 0 that's in 300, 3 and 500. Is this ringing bells from last year? So that part is not new. We're just upping the ante with more complex numbers. So all of these are zeros. That makes the second level really easy. And then the last level is green. You see how I drew a green line from the 3 to the 8, the 3 to the 5, the 3 to the 6, and the 3 to the 3. Do you see the colors here? That's what you have to do for the final level. But look where the 4 is lining up with. The 4 is lining up with the 3 in our original problem. I know it's not perfectly lined up because I didn't have columns, but you should have 2 spaces here to make sure it's lined up. That's the hardest, I think, trickiest part of this. If you don't line it up correctly, then there's a possibility that you could be adding the 4 and the 9 when you shouldn't. It's just 9 plus 0 plus 0. If you want to replace those X's with zeros, that's also possible and helpful as well. Or the final answer, when you add it up, I know you're itching maybe for that, is that decimal. But here's the new piece. There are 3 decimal places in the first factor, 2 decimal places in the second factor. What's 3 plus 2, everyone? 5. And you have to start from the right and then count 5 places putting the decimal point in between those two ones to make the answer 11 and 1,569 and thousands. I think it's the place value, 10,000. So these do take some time. I'm going to give you another one to try to practice. If you want to use the colored pencils that are in front of you and do that line thing every level, that is an option. That's why I took the time to make sure they were available. You don't have to, but sometimes it keeps my brain straight. The only problem with colored pencils is that they don't erase. Ladies, thank you. So let's go to the next question, and then we'll try some more. So, Madeline studies honeybees. Listen up, there's 3 numbers here. We want to make sure we're understanding the problem before we just start randomly picking numbers and multiplying. Every week, she weighs the same honeybee hive. The first week, the hive weighs 11 and 607,000 kilograms. Its weight increases about 204,000 kilograms every week. At this rate, how many kilograms will it increase in 7.5 weeks? So what are we multiplying together? What 2 numbers? Think about it. What 2 numbers might we need to multiply together? We have 3 of them in the problem. That's why I want you to think about it. What do you think, Ayana? So we don't need the weight at first. All we need are the last 2 numbers, the 7.5 and the 204,000. Now question, does it matter which number we multiply on top or the bottom? No, it doesn't matter. So I would be smart about my setup here. Do I want to multiply and have 3 different levels or just 2 different levels?
2.
So what number should I write down first?
7.5. No. Sorry. 0.6.
The 204,000s I would write first, then multiply it by 7.5. Then you only have to use 2 colors, not 3. So be smart about the setup. It doesn't matter which order you put the numbers in. Try it.
I got it.
Putting the decimal, you have to count the number of places
Yeah.
that you have in your factors.
No.
It's not. Start here.
Oh, this number?
Exactly right. So I'm putting my 204 first. You can see my colors, keeping straight. 4 times 5, 5 times 0, 5 times 2. That gives you the first row.
I did that one.
The first row is 1020. Notice you have to make sure you're adding up that 2 and 1 when you're multiplying. Those carryovers are important. And then the second level ends up being 1428. Now I didn't write this, but I would encourage you to either use that 0 and X or draw an X so that you're moving that 8 over so it's in line with the 7. That's also very important. All right. And then when your final answer with the movement of the decimal places, let me review that new part. There are 3 decimal places in the first factor, 1 decimal place in the second. And so we start at the end of the problem and go 1, 2, 3, 4. So you always start on the right and scoop to the left. Isn't there a song like that?
Oh, I did it.
Okay, we're scooping to the left. Little foreshadowing tomorrow on Monday. Guess what? We're gonna scoop to the right.
What?
When we're dividing. So go ahead and so I'm not the only one scooping. Let's scoop to the left. To the left. To the left. When we're multiplying, hold on, I feel a chant coming on here. When we're multiplying, we scoop to the left. To the left. When we divide, guess what? We scoop to the right. To the right. So stay tuned for the division. That's going to be the new one on Monday. So yay for scooping to the left and right. All right, let's try another one. Kind of gross to think about. That's why this is so cool. So let's listen. This is kind of gross to think about. So, your fingernails. Listen. I'm reading it because I'm also filming this for people who are out today.
Oh.
So, hi, if you're home. Your fingernails grow, nobody is there. I'm just filming the instructions so they won't feel totally lost when they get back on Monday. Your fingernails grow at an average rate of 2¼ inches per year. If they grew at that rate and you never cut them, that's what makes this kind of weird. Yep. How much would your fingernails grow in 4½ years? So multiply away, set it up. Try this one. How long would your fingernails be in 4½ years? Try it.
Like 2.25 was on the top. I bite my nails.
Try it.
So it's
And for those of you at home, we're going to be practicing more, and that's really the basic idea. So hopefully this helped you. You can practice when you get back on Monday, but that's what I wanted to at least teach you via the good old YouTube. So I will see you on Monday. Thanks, guys.
Oh.